I'm going to talk a little bit about the renewal objectives for years 6 through 9. So these are the topics that we have proposed to NSF that we'd work on as a center for you, the community. So this is what we are preliminarily going to do and what we've charted. But if there are things that you would like to see done that are not in this list, you should let us know, because we're here to respond to the community's needs also. So, but these are things that we have identified from the community already. So the breakdown for the next 4 years is broken out into sort of 6 objectives. There are 4 research objectives and 2 educational objectives. And each of the research objectives is broken out into discrete strategies for addressing those objectives. And within those strategies, there are a number of activities that have been planned. They sort of compose those strategies. So at a high level, the 4 research objectives have to do with integration of hazards and hazard modeling. And then the next objective has to do with advancing local scale computational modeling associated with buildings and infrastructure subjected to natural hazards. The third objective is related to the regional types of calculations. So not just looking at an individual building or structure in detail, but looking at a whole portfolio of structures across a region, say the San Francisco Bay Area, which is our standard test bed since a lot of us are here in California, but also we did things like Hurricane Laura and things like that. And then the fourth research objective is around integrating tools that reach out to the social sciences and the urban planner. So the front end, the back end of what we typically deal with as engineers. And then we have 2 research objectives associated with reaching out to the community with education and promoting simulation, and also community building. And so those are, and we'll hear about those in the second part of today's sort of workshop here. So, but let me talk a little bit about the different objectives that we have here. And I'll start with sort of the hazard integration. And so this objective relates to incorporating work into workflows from researchers simulating natural hazards. And there are basically 3 strategies here. One is interfacing other hazard modeling codes. And so what we want to be able to do is incorporate simulation applications that can just be launched directly as part of the workflows. And then also creating databases for utilizing previously run simulations, because some of these hazard codes are very compute intensive. So we just want to be able to read in simulations, say things from AdCert, for instance, and using those stored results of those previous simulations directly in analyses, or creating also surrogate models using the results of past simulations for analyses, especially if we're doing uncertainty quantification. We really need to have surrogate models for these types of things. So that's another big part of the strategies for incorporating hazard tools. And the third part of this is to engage with the natural hazards engineering agencies to leverage things that the agencies had developed already, because there are a lot of tools out there that have been developed by things like USGS and things like that. And we'd like to make those elements or those models and codes available within the workflow, so that if you want to take advantage of them, you can just sort of with a click of a button take advantage of those softwares. So, and a broader objective here is also to bring in hazards scientists to work more directly with the people doing structural engineering and also urban planning and things like that. So this is the first research objective for the continuation. The second objective is kind of builds off that, and so bringing in the hazard is advancing local scale modeling. This is the kind of thing that is done in a lot of the NERI facilities, where you put up a single structure or a component and you subject it to some type of loading and do measurement. And this objective really looks at improving the simulation of the response of components and buildings. And this is really an integral part of our workflow, because there's a lot of engineering that still needs to be done just at the component level and the building level, but also these types of simulations and models are used then also in the regional calculations. So, and within the scope here, we've identified fluid structure interaction as something that is lagging behind in simulation technology. The earthquake engineering types of loading, the seismic loadings are in much better shape. And so one of the big strategies or strategic pushes here is advancing the fluid analysis options, both in our hydrodynamic code and in our wind code. And for those of you that are in the CFD regime, you know how compute intensive these types of analyses are. And so a big part of this strategy is also to work on surrogate models and reduced order models within this framework here. So that's sort of the second strategy within the local scale modeling work that we plan to do. The third strategy has to do here with the fact that there's a lot of uncertainties in these types of problems. And when you start to really look at the problems in detail, you realize that you're looking at high dimensional uncertainty quantification problems. And so a third strategy here under this objective is to provide tools for doing high dimensional uncertainty quantification within the context of natural hazards engineering. So we have a whole team that works on uncertainty quantification, and one of their mandates is to make available modern tools for doing high dimensional uncertainty quantification for these types of problems. The other strategy that we're looking at building out within the local scale modeling framework is providing tools for doing multi-scale modeling and also multi-model types of methodologies, so that if you want to do a simulation of a building, you can have a calculation that uses different types of models at the same time to be able to get the computations to run to the accuracy that you're looking at as quickly as possible. So these are all four strategies that we have planned out within the local scale modeling objective. Also within this objective here is we're building out features to support the facilities. And for example, we have a project going right now to build out a way in which that we have a digital twin, say, of the wave flume at Oregon State, so that if you're doing experiments up at OSU, you can quickly have a setup that has the flume set up. You can put your experimental model in the calculation, and you can run the workflow directly on the flume. So you basically have a digital twin of your experiment before you go ahead and run the experiment. So it can help you plan out experiments. So this is something that we're building out with various facilities also. So that fits within this objective here. Moving on in scale, the third big objective for the renewal has to do with high resolution models for regional scale risk. And within this, we have 5 strategies that we feel are necessary to sort of improve upon from what we have. One has to do with inventory and databases. So to do regional simulations, you need to know what the inventory of the region is. And so we have a lot of tools for machine learning and AI base for helping construct inventories so you can actually do regional simulations. And so we have some tools in place, but part of the renewal will be expanding those tools and their capabilities to deal with other types of things, say transportation systems and piping networks and things of that variety. The second one has to do with allowing you to do these types of regional simulations and test beds seamlessly. We have some worked out. You've seen Greg mentioned about the earthquake types of regional simulations and the hurricanes, but we're continuing to work on those during the renewal. And regional lifelines also are a big part of this, things like gas networks and water networks. We have preliminary infrastructure for doing these, but we're continuing to improve upon that. The fourth strategy has to do with damage and loss assessment, in particular for wind and water hazards. We have fairly sophisticated damage and loss software for seismic hazards. and basically FEMA P58 types of things. But we're working. We have software elements also for wind and water hazards that we're trying to make a little bit more sophisticated. So that's the fourth strategy here. And the fifth strategy has to do, again, I've mentioned previously on previous slides, is about when you're looking at these types of simulations, regional in particular, they're very high dimensional uncertainties associated with them. And when you're looking at regions also, that's correlated hazards from point to point. And there's a lack of uncertainty quantification tools out there. And so we're working on building those out also, because it's real important if you're doing regional calculations that you also understand that these aren't point estimates of what's going to happen. They are elements of a distribution due to all the uncertainties in the hazard and in the inventory that you're looking at in the models also. And so we are working on building that software out also. And there are lots of opportunities for collaborations there and working with us to achieve those objectives there. So that's the third main research objective. The last research objective has to do with socio-economic effects and recovery. And within this part, this is sort of a stretch for engineers, but we've brought in social scientists into the team to help us with this. And we hope this will increase the broader impact of the SimCenter. And here we have really three strategies. One is just simply working with social scientists and urban planners and recovery modelers to understand what they need and trying to communicate to them what we can do as engineers. And as an example of something like that, we had a workshop right before the start of the pandemic where we tried to develop an ontology, so a language within which we could communicate with each other on that front. And we're continuing to do that work in the renewal here. Another strategy under this objective is to work on recovery models, and in particular do things such as incorporate the in core models that do prediction of recovery after hazards. So we've been looking at in core but also other types of recovery models, and we'd like to incorporate those into the workflow also during the renewal. And the last strategy that we're going to work on in this framework is the incorporation of resilience, environmental impact measures, and equity measures into the outputs of what our software or regional software can produce, and trying to develop ways to communicate this, in particular visual communication here.